All right, here are the answers to homework number 4. Check them out. All right, let's work our way through them. Problem number 1 is one of these break-even problems. And looks like printing a newsletter costs $1.50 per copy plus $450 in fees. All right, so in these break-even problems, X is going to equal the number of things sold, in this case copies, and Y is going to equal money. And I'm going to have two equations. I'm going to have a cost equation and an income equation, right? The cost equation is right here. I underlined it for you. That would be that Y, the amount of money for cost, that's Y, is equal to $1.50 times X, $1.50 times the number of copies, plus $450. My income equation is right here. The amount of money I make is $3 each, so 3 times X. So, to solve this, I would use the substitution method. I would go ahead and take what Y equals and substitute it over here in place of the Y. And that would look like that. And I'd go ahead and solve that for X. I'd subtract $1.50 X from both sides. That gives me $1.50 X equals 450. And then I would go ahead and divide both sides by $1.50. Oops, uh-oh. And I would get 450 divided by $1.50 is a weird number. I don't like that. 450 divided by 1.5. What is going on with that calculator? Well, let's see, it's 300, right? It is. So X equals 300, and if I plugged it back in up there, I would find out that Y equals 900, not that I need Y. So my answer to this question, how many copies? That's X. X is 300, and therefore they must sell 300 copies to break even. Okay. Question 2 is a mixture problem. It looks like the two things I'm mixing together, 30% gold alloy and a 10% gold alloy. And I want to combine them to make 4 kilograms. Okay, so X is going to be kilograms of 30% alloy, and Y is going to be how many kilograms of the 10% alloy I use. All right. Because I want to combine them to make 4 kilograms, I know that the kilograms of the 30% alloy plus the kilograms of the 10% alloy need to add up to 4. And then I'm going to actually calculate the amount of gold in each thing. So the amount of gold in X kilograms is 0.30 X. The amount of gold in the Y kilograms is 0.10 Y. And the amount of gold in the mixture is 0.15 times 4. And 0.15 times 4 is 0.6. All right, if I were solving this, I would solve it using the elimination method. I'm going to go ahead and multiply this equation, the top equation, by negative 0.10. That gives me negative 0.10x, negative 0.10y, and negative 0.4. And the bottom equation, I'm just going to leave it alone. And so when I add these together, the y's cancel out. Negative 0.10x and 0.30y would be 0.20x, and negative 0.4 and positive 0.6 would be 0.2. So then to solve for x, I would divide by 0.2, and I would get x equals 1. And substituting that back into the first equation, I would get y equals 3 when x equals 1. So I can answer my question. If x is 1, that means I'm going to use 1 kilogram of the 30% alloy and 3 kilogram of the 10% alloy. Question number 3. All right, what is the bird's airspeed? So I'm going to have x equal the bird's speed and y equal the wind speed. All right, these equations are all the same. I've got an equation with the wind, and I've got an equation against the wind. With the wind, my equation is always the speed of the object plus the speed of the wind, or the current. And against the wind, my equation is always the speed of the object minus the speed of the wind. I just need to plug in the numbers from the problem. It says that with a tailwind, 3 miles per hour. Against the wind, 1.5 miles per hour. So there's my two equations. These are easiest solved by the elimination method. I'd go ahead and take this second equation and write it underneath this one. And I can add those together, and the y's will cancel out. So I get 2x equals 4.5. Or if I divide both sides by 2, I get x equals 2.25. And substituting that back into the first equation, I would get 2.25 plus y equals 3, or y equals 0.75 if you subtract 2.25 from both sides. So then I can write my therefore statement. Therefore, let's see, x is the bird's speed, so the bird can fly 2.25 miles per hour, and the wind speed is 0.75 miles per hour. All right, let's look at number 4. Number 4 is another mixture problem. I think the numbers don't work out very nicely for this one. Let's see, I'm combining 42% real cranberry juice with 60% real cranberry juice. And I want to make 5 liters of juice that's 53% real cranberry juice. So, how much of each should I use? X will be the amount of, let's put it instead of amount, let's say liters. I think that's a better description. Liters of 42%, and Y will be liters of 60%. How many liters of each one should I use to make a mixture that is 53%? So, that is my first equation, the amount of each one I'm going to use. I'm going to use X liters of the 42% plus Y liters of the 60%, and that will make 5 total liters. All right? 5 total liters. And then I do the percents of each one. This is actually calculating how much cranberry juice is actually in each one. In X liters, there's 42%, 42% times X would calculate the amount of cranberry juice in X liters. And 0.60Y would calculate how much cranberry juice is in the second brand. And the mixture has 53% cranberry juice, so 0.53 times 5 would calculate how much cranberry juice is in the mixture. And that turns out to be 2.65 liters. So there's my 2 equations. Again, you could solve this by substitution or elimination. I prefer elimination. So I'm going to go ahead and multiply this first equation by negative 0.42. That gives me negative 0.42x, negative 0.42y, and 0.42 times 5 would be negative 2.1. I'm going to go ahead and leave the second equation alone. That would be 0.42x plus 0.60y, and that equals 2.65. Now I can add these together. The x's will cancel out. The y's, 0.60 and negative 0.42, would be 0.18. And 2.65 and negative 2.1 would be, sadly, 0.55. I can solve that by dividing by 0.18, and I get y equals, and I get a decimal, and I guess technically if I'm going to go to, you know what, I know on the answers I gave 2 decimal places. I'm going to do it to 1 decimal place here. It is 3.05, repeating. So I'm going to go ahead and round to the nearest tenth and make it 3.1. And then when I take that and I substitute it back into this first equation, I would have x plus 3.1 equals 5. And I would subtract 3.1 from both sides and get x equals 1.9. So I am ready to write my therefore statement. And my therefore statement would be, therefore, you should use 1.9 liters of the 42% juice and 3.1 liters of the 60% juice. All right. Brenda has has 14 fewer apps than Caleb. If Caleb deleted 5 apps, he would have twice as many as Brenda. How many apps do they each currently have? So this is kind of key right here. This is what I'm trying to solve, so I'm going to make that my variables. X will be number apps Caleb, and Y will be number of apps Brenda. And now I need my 2 equations. This one's a little different than the other ones. It says here that Brenda has 14 fewer apps than Caleb. So I could say that Brenda equals Caleb minus 14, right? So Brenda is Y, and she has the same number as Caleb minus 14 because she has 14 fewer apps. So I took the X, which is the number of apps Caleb has, and subtracted 14 to equal the number Brenda has. All right, my other equation would be here. If Caleb deleted 5 apps, he would have twice as many as Brenda. So, if Caleb deleted 5 apps, he'd have X minus 5. And that is equal to twice Brenda. So that would be twice Y. And there's my 2 equations. I would then go ahead and solve that. I would use substitution. I would take what Y equals and substitute it over here in place of the Y. So I would go ahead and rewrite the second equation. X minus 5 equals, instead of 2 times Y, 2 times X minus 14. Solving for X, that would give me 2X minus 28. I would probably subtract X from both sides, giving me negative 5 equals X minus 28. And I would add 28 to both sides, giving me X equals 23. Substituting that back into the first one, I get Y equals 23 minus 14, or Y equals 9. So I can go ahead and write my therefore statement then. Therefore, Caleb has, let's see, Caleb is X, so Caleb is 23 apps, and Brenda has 9 apps. And the last question is another mixture problem. Let's see, it says that he invested $7,800, so that's his total amount invested into investments. How much did he invest in each? So I'm going to have X be where's his first investment? The first one paid 8%. So that would be dollars invested at 8%. And the second one paid him 12%. So Y is going to equal dollars invested at 12%. And I'm ready to go ahead and write my equation. The first equation is just going to be like it always is on these mixture problems. Here's his total amount. He's mixing these 2 investments together, and the total amount he invests is $7,800. So the amount he invested at 8% plus the amount he invested at 12% adds up to the total amount invested, $7,800. And the second equation is going to deal with the percents. The first one paid him 8%. So 8% times the amount invested would be how much money he made in interest. Plus 12% times the amount invested would be how much money the second investment paid him in interest. And that would equal the total amount he made in interest, which is right here, $768. And so, I'm going to go ahead and multiply this first equation by negative 0.08, and I'm going to put it below the second equation. Negative 0.08x minus 0.08y would equal 7,800 times 0.08. That gives me negative 624. I am now ready to go ahead and add these two equations together. The x's cancel out. The y's would be 0.04y. And 768 minus 624 is 144. I can go ahead and divide that by 0.04 and get y equals 144 divided by 0.04, $3,600. And as usual, I would go ahead and use this equation and get x plus 3,600 equals 7,800. And that would be x equals 4,200 when I subtract 3,600 from both sides. So I can write my therefore statement then. Therefore, let's see, that is the 8%. He invested $4,200 at 8% and $3,600 at 12%. All right, hope that helps.